Hey everyone, welcome to Splunk Tech Talks. Our DevOps edition today is focused on the brand new Observability Suite, renamed Splunk Observability Cloud. Tech Talks is a series of short webinars that are deep dives for technical practitioners. We value you, our customer, and we want to make sure you continue your Splunk journey. Our experts help create these best practices, and we want you to leverage them in your daily role. I'm Nico Graham, an Observability PMM here at Splunk, and I'm excited to share with you information about one of our most highly anticipated product releases, Splunk Observability Cloud, again formerly known as Observability Suite, and introduce my colleague, Bill Grant.
Hi, I'm Bill Grant. I'm a senior sales engineer in Splunk Observability, and I'm looking forward to showing you the demo today.
Thanks, Bill. Before we kick off the demo, let me run through the agenda and some slides. So today I'm going to talk about the observability telemetry types, i.e. metrics, traces, and logs, some benefits of GDI or getting data in with OpenTelemetry. I'm going to introduce the new Observability Cloud and the importance of related content to make your investigations easier, cool feature of Observability Cloud. And of course, you'll get a demo on how to leverage Observability Cloud for monitoring, troubleshooting, and investigation. At the end, we will cover additional resources available to help you take advantage of Splunk Observability Cloud, and our team will be available for Q&A throughout. So don't be shy. Go over to the Q&A widget within your screen, and if you watch a recorded version of this webinar, please continue the conversation through the Tech Talk discussions in the Splunk community. Let's get started. So this may be a little refresher here for some of you, but what are metrics, traces, and logs, or the observability telemetry trifecta, as I like to refer to it? And really, why are all three types necessary to do observability right? Well, first, we have metrics. A metric is a measurement related to the health, capacity, or performance of a given resource. Those resources can be found in all our favorite things, right, like systems, networks, or applications and services. And metrics really help us monitor and usually tell us if we have a problem. Next is a trace, which is a collection of spans or calls in the trace that represents a full request path. These are really critical to collect and analyze in microservices environments. Traces are great for troubleshooting, and they tell us where the problem is. And finally, a log, which I know all you Splunk users are familiar with. A log is the record of a discrete event in the system, application environment, or any other element. Not talking earth, wind, or fire here, but you can think of this as the record of a change of state in the environment. And logs help us with root cause analysis and really tell us why a problem happened. While all three data sources are important, different groups tend to depend on different data more. Here's where we see our practitioners like you often splitting their time. So our SRE and DevOps engineers live and die in metrics. Metrics drive alerts, of course, the things that wake them up at night, but metrics also allow us to quickly grasp that things are working well, especially when displayed on dashboards. When things do go wrong, and hopefully that doesn't happen too often, there is a need to identify the problem areas and respond and resolve quickly. Here's where we see traces appear, and they're equally useful to the SREs and the software engineers. Developers, though, are quite often log-centric. The logs tell them what is going on in the code and gives them insights that can be unique. However, developers don't live in logs the same way SREs live in metrics, and usually only go into them when there is an issue. But of course, with the growing adoption of DevOps practices, these lines may blur. In all cases, expect software engineers to be interested in the metrics and SREs to venture into the logs. Ultimately, all telemetry data tells us something important about our systems. Remember, when something happens, a failure, a slowdown, anything, each piece or telemetry data provides unique insights that can help different people learn different things. Again, is something wrong? Where is it wrong? And why is it wrong? From our data comes our monitoring and observability, including our analysis and our projected response. And since all this data works together to tell a story, it needs to be correlated so we can effectively do observability, or really add that analytics, response, and optimization piece. So data points are great, but how do we bring them all together to get that correlation? Well, you just saw it up here. It's OpenTelemetry. OpenTelemetry is looking to solve the instrumentation and data collection side of the observability equation. So it does not offer a backend, but it is open source and vendor agnostic, making it easy to support switching backends or using multiple in parallel to fit your use cases. In other words, it provides a single agent and a collector to capture all the observability data, so the metrics, traces, and logs that I kept talking about. Since it ensures all the data is aligned at collection, OpenTelemetry enables context-aware workflows across the metrics, traces, and logs to really help reduce MTTR, or mean time to resolution, which is really important because observability is more than traces, metrics, and logs, right? It's really, again, about analyzing the data to understand what is going on with our apps and infra, and it's the proxy for our customer experiences. So when issues arise, we really need to resolve them quickly. So context-rich, highly correlated data means simpler deployments, metricized traces and logs for rich visualizations, no dead-end troubleshooting for faster MTTR, and analytics-driven recommendations throughout your workflows. So since monitoring and troubleshooting are not a straight sequence of events, but rather really a series of hypotheses that we need to test, be wrong about, dig deeper in, and sometimes backtrack, it's important to be able to go from metrics to trace to log to trace to metrics, and all the combinations without hitting dead ends and without having to keep contextual information in your head. And this is really where observability is evolving towards. And that's why we're really excited about Splunk Observability Cloud. Observability Cloud combines all our products into a single, tightly integrated user experience that really gives you a seamless and streamlined workflow for monitoring, troubleshooting, and investigation, because it embraces OpenTelemetry, or OTel as we like to call it, and it leverages a unified entity model in order to surface relevant information within your environment for, again, a continuous, no dead ends experience when exploring and troubleshooting issues, and provides that relevant contextual information correlated through the metadata that comes in with OpenTelemetry to really reduce mean time to resolution significantly. So yes, context is critical, and we've ensured that customers' monitoring and debugging journeys allow them to flow easily across metrics, traces, and logs while they hone in on a root cause of a problem. So we've expressed some of this directly in each pillar. For example, RUM will funnel, or real user monitoring will funnel customers into APM, or application performance monitoring, once they found a problematic session or endpoint. However, we can't predict every journey that a customer is going to take, especially with all the complexity from modern systems. So to that end, we've dedicated the bottom portion of the screen in the user interface to related content. So this bar will always contain links to other pillars that can show information about the service or piece of infrastructure that is currently being investigated. So for example, if you click on a service in APM, you'll be presented with links to views of that service's infrastructure in infrastructure monitoring, and to logs generated by that service in Log Observer. But with that example being said, it's always better to see it in action. So let me pass it to Bill to give you a walkthrough of some of the new capabilities of Splunk Observability Cloud, including the related content I just talked about.
In this demo, you will see how we can easily get data into Splunk Observability Cloud using Splunk's distribution for OpenTelemetry. Splunk's distribution makes it easy to configure for Splunk's backend, but because it's OpenTelemetry, a customer can still easily migrate to another vendor should their requirements change. We'll also see how to use Splunk's new real user monitoring to easily identify performance degradations and errors from a real user's perspective. This solution is a good partner to Splunk's synthetic monitoring solution, which uses simulated user interactions to identify slowness, as well as provides optimization recommendations. It also partners well with Splunk APM, giving full traceability between front-end and back-end transactions. Next, we'll do a short tour to see how metrics, traces, and logs are connected using a new capability called related content. These boxes at the bottom of the screen provide an easy way to navigate between these essential signals to pinpoint problems in our applications and underlying infrastructure. And finally, we will look at Splunk's Log Observer, which offers a low-code approach to log querying that's purpose-built for DevOps use cases. It gives a live tail view of logs for monitoring real time, and it provides an easy way to add new metrics from logs. Let's start by getting data into the system. Splunk's engineers have put a big focus on this new release to make it even easier to get data into Splunk. In the past, we've used Smart Agent to bring information into Splunk Observability Cloud, and we will still support customers using this method for some time. But our new recommendation is using the Splunk OTel collector. This distribution offers the easiest way to collect data and the official way to get Splunk support. The current package pairs the OTel collector with FluentD for collecting logs. This will be replaced with the OTel collector's log collecting ability once that has been released. Splunk Observability Cloud provides an easy wizard to guide us to getting set up. You see several tiles here in the beta, and we will add even more tiles at GA and going forward. Today we will demonstrate installing directly in Linux, but we also have an easy way to deploy in Kubernetes, for example. As I begin the setup, I can select from any of the available access tokens, which are long-lived tokens you can use to segregate your organization and each subgroup's usage and rate limits. In addition, you can specify the mode of your agent, whether it is running as an agent or as a gateway. The Splunk OTel collector script includes everything I need to install and run the agent. If I have any additional configuration to do, the wizard guides me through that process as well. I'll kick off the install now, give it a few seconds to install, and then I can return to Splunk Observability Cloud and see my new host arrive. Next, let's look at real user monitoring. The OTel collector gives us a way to collect metrics and logs, but we'll need instrumentation to collect traces and additional metrics from our front-end applications in the form of real user monitoring, or RUM. We also need instrumentation for our backends in the form of application performance monitoring, or APM. RUM is a new solution from Splunk. Here we are using the Splunk distro of OTel JavaScript browser to instrument the front end of our application. RUM uses its own kind of token that is specific to RUM, but it's really easy to add this small snippet to your page and start collecting metrics and traces automatically. Here we can see our demo application that's capturing RUM metrics. The application is a cloud-native 10-tier microservices application made by Google, which serves as a great way to demonstrate cloud technologies, including distributed tracing. We've taken this application and introduced some problems to demonstrate how customers can use the Splunk Observability Cloud to solve these real-world problems. Here in the RUM view, we can see a number of critical metrics that real users would be disappointed by, such as an incredibly slow checkout process. We can also see we are getting front-end errors in our cart process. In addition, we can see metrics on key web metrics, such as the largest contentful paint, which tells us when the largest content element in the viewport becomes visible. 13.5 seconds is clearly unacceptable if we want to keep happy customers and keep those customers with us. Let's look more into this checkout page load time. Here we can see these key metrics associated with different dimensions of data to understand if the impact is specific to a particular version of code, browser, OS, etc. If we look at another example of such a view, we can see how useful it can be to use filtering, pinning, and hovering to get a good perspective on our data. Switching back to our application, we can zoom in on one of the sessions we are interested in to understand it better. This gives us a waterfall view of each interaction with metadata on each step, as well as APM links to see those interactions from the server side. The product fetch action that took 53 seconds has a server-side trace that we can investigate further. We can either jump to the service diagram for this workflow or jump right into the waterfall diagram. Let's go to the service diagram today. Here we can see the services involved in the checkout process. We can see the delays as well as a large number of errors that we would certainly want to investigate further. Let's step away from our troubleshooting flow to talk about another new capability in the Observability Cloud, related content. As I click on different services in the map, I am given additional breadcrumbs to investigate further. For example, if I click on the checkout service, I am given related content to look at the Kubernetes information for it, as well as the logs for that service. Once I've arrived at the infrastructure view, I can either jump back to the service map or continue into the logs. This makes it very easy for me to move between different connected data. For the last demo, let's look at Log Observer. We'll look at all of our logs for this application for a 5-minute window. Log Observer offers a new way to navigate and query logs that's purpose-built for DevOps use cases. Let's do a few things with the data to show some examples. We can easily add values to the filter by clicking on the graph legend or clicking on fields. We can save queries for later, make queries private or available to other users, and we can make queries the default when using Log Observer. We can also easily perform counts, sums, averages, or other common calculations. We can also easily turn logs into metrics, which is extremely powerful. In this example, we are summing currencies. We can define what token this MTS will go against, review what the impact would be to our custom metric count, and begin ingesting our metric. Finally, let's look at LiveTail. Tailing logs has been a common investigative practice. One example use case might be to monitor our system as we deploy a fix to ensure that that error message has gone away in real time. So, to wrap things up, in this demo, we saw how easy it was to install the Splunk OTel collector to get data in. We saw how we could use real user monitoring to see how real users see our systems. This gives end-to-end tracing, which Splunk uniquely offers with its full fidelity, no sample ingest. We saw how easy it was to navigate throughout the UI and between signals using Splunk's related content capability. And we saw how Log Observer gives us a DevOps-oriented capability for working with logs, including seamlessly adding new metrics and leveraging LiveTail for real-time log monitoring. Back to you, Nico.
Great. Thank you so much, Bill, for the awesome demo. We're about ready to wrap up this Tech Talk, but before we do, I wanted to quickly share the resources available to you to continue your journey. You will receive these assets in a follow-up email as well as the recording. Finally, don't forget that we have an incredible community of Splunk users on our community site. So you can search the answers section on DevOps or observability. You can continue the conversation for this talk within the discussion section called Tech Talk. And finally, there is Splunk Ideas, where you can submit new product enhancements or vote for current ideas from other customers. We really appreciate you taking the time out of your schedules to join us today. Please tune back in for future Tech Talks. We are excited to share the series with you.